Hey guys, and welcome to this video. In this video, we are going to be working on the calculus section of the May-June 2025 paper 1 exam. Okay, so this is the senior certificate exam, and here we go. Okay, so the first question, 8.1 says, determine f prime of x from first principles if it is given that f of x is equal to this. So first things first, find f of x plus h since we are using first principles. So in place of x, wherever you see x, replace it with x plus h. I see x over there, so it gets an x plus h. But that is squared, so it gets squared. And this is equal to, when you square this, you can square the first term, giving you x squared, square the last term, giving you h squared, and first term times second term is xh, and then you just multiply that by 2, which is positive 2xh. Okay, and then we have minus 2. So f prime of x is equal to the limit as h approaches 0, and we're going to go ahead and put, so f of x plus h minus f of x all over h. Okay, so let's substitute. The whole point is make sure that the denominator does not equal 0. So we have that plus h squared minus 2, then minus f of x. You see that it has two terms, so you need to protect that with brackets. So we're going to say x squared minus 2, and then it goes all over h. And I just realized I forgot to write the limit. Okay, so we need to make sure we write that. Okay, because we're finding the limit. So here we have this, and again, the limit as h approaches 0, and we have x squared plus 2xh plus h squared minus 2, and then that multiplies in to give you a negative x squared and positive 2, which of course will cancel with whatever the additive inverses are. So we have the limit as h approaches 0, and then these cancel. So that's going to cancel with that, and that's going to cancel with that. And then all you have left is this. So 2xh plus h squared all over h. And you see now that we can take h out as a common factor. So the limit as h approaches 0, and we have h out as a common factor. So 2x is left, and then plus h and all over h. And now those two h's cancel. Now we don't have that problem of the denominator becoming 0 anymore. So the limit as h approaches 0, I'm just going to represent it one more time like that. And now we can finally substitute. So f prime of x is finally equal to 2x. And then in place of h, we substitute 0. So this is equal to 2x. Okay, that is the gradient of that function. Moving on to the next question. The next question, 8.2.1, asks us to determine, and we have to find the derivative of this function. So, okay, remember when it's written like this, you're just going to, if it needs to be prepared, you will continue writing d over dx. But this one is perfectly fine. So we can go ahead and start deriving. So we'll say equal to and derive. Coefficient times exponent is going to be 6x, and then minus 1, it's 1, but you don't have to write that. And then again, same thing, minus 4, and the x falls away because of exponent of 1 minus 1 gives you 0. Anything to the power of 0 is 1. So that is that answer. Moving on to the next question. The next question, 8.2.2, says we have to find g prime of x if g of x is equal to this. So do you see now this one, it still needs some working on before we can actually derive it. So the problems here that we have is we have got a surd, and we also have this being squared. You have to actually distribute them because I'm not just going to derive like that. So this is equal to negative 2, and you have the square root of x. Rationalize the exponent. So rewrite this so that it has a rational exponent. So we're going to leave x here. Remember, the square root of x, there's an invisible 2 here, and the exponent of x is 1. So you're going to leave the base, and you're going to say the inside exponent over the outside exponent. So that gives us x to the power of 1 over 2, and we are multiplying by x minus 1 all squared. So x all squared gives you x squared, and then negative 1 all squared gives you positive 1. Then x times negative 1 is negative x, and then you multiply that by 2. So that's minus 2x that we have there. Okay, then g of x is equal to, and we can now start distributing in. So when you're multiplying, you see we're going to have negative 2, but then the x's multiply. And what happens to the exponents? Because the bases are the same, the exponents get added. So what is a half plus 2? That's going to give us 5 over 2. Okay, and then we have that multiplies, and you're going to get a positive 4 now. And then x, we have a half here, and the exponent here is an invisible 1. So 1 plus a half is 3 over 2. So 4x to the power of 3 over 2. And then lastly, those two multiply, and we have negative 2x to the power of a half. And now it's ready to be derived. So g prime of x is equal to coefficient times exponent. And I realized that I didn't even put the x here. Sorry about that. So coefficient times exponent is going to be, you see this is a negative 2 times 5 over 2. What happens with the 2's? They will cancel. So you're left with negative 5x. And then you have 5 over 2 minus 1, which can be looked at as 2 over 2, which is 3 over 2. Okay, then here, same thing happens. So 4 and 3 over 2. 2 would cancel here, 2 would cancel here. You're left with 2. So that's 2 times 3, which is positive 6. And then x, and you're going to say exponent minus 1, which is in the form of 2 over 2, which is just going to be 1 over 2. Same thing over here. So 2 times a half. That's going to cancel, but remember it's negative, so it's minus. And then we have x, and then a half minus 1, which will give you negative a half. Okay, so that's what we have. 4 marks. You can leave it like that. Don't really have to make the exponent positive. At this point, it's fine. So that is it for that question. Moving on to the next question. Okay, 8.3 says, given that y is equal to 4x minus 14 is a common tangent to f of x, which is this, and g of x, which is that. Calculate the values of a and b. Okay, we can just visualize what's going on here. So they're asking you for two things. So you're probably going to need two equations, two pieces of information to answer this. So we have a common tangent first of all. Please notice that this tangent is an increasing function because it has a positive gradient. Okay, so it maybe looks like that, right? So that is the y equals, and it may not take so much space, so we'll just put it here. Y equals 4x minus 14, right? We have that. And then it is a common tangent to two parabolas. The first one we can clearly see is a concave up parabola. So maybe that one looks like this, it's a tangent to it. It only touches it at one point. So maybe like that. And then at that same point, there's another parabola that is also a tangent to it. Okay, so for it to be a tangent at that same point, okay, so remember this is f, right? For it to be a tangent at the same point, the second one can't really be a concave up parabola because then it won't even be on that point. It will either just be sitting, that doesn't make sense. So it's probably a concave down parabola. So maybe like that. And then it's also a tangent at that point. So something like that. Okay. So that will be G. Okay. So we have our graphs and we can see a visual representation of what that would maybe look like. Okay. So let's see how this is going to fit into everything. The point is to find this, right? That's the whole goal. Find that. We know that it's a tangent at this point. We know the gradient of that line. So in order to find A and B, first, what we can do is find that point of intersection. Okay, it is important. You can find it now, I guess. It's not a problem. It would help us. Okay, so let's see. When we find the point of intersection, you're trying to find out because the only graph that you fully have right now is f, right? We have all the values there, the coefficients. So since we have this, and we know that it lies on this same line, okay, and it's a tangent at this point. So You could equate them, but that may also just confuse things because you're going to get two x values. So what you can do is say, at this point, right, to find the point of intersection, the graph of f, its gradient is going to be exactly the same as the gradient of the tangent at that particular point. So what is the gradient of the tangent? It's 4. So we're really just working on this. F prime of x is equal to 4. So let's derive f. Okay, so when deriving, we're going to say coefficient times exponent. So you have 4x and then minus 4 is equal to 4. Then you can take that over. So we have 4x is equal to positive 8. And if you divide both hand sides by 4, x will therefore be equal to that 8 over 4, which is 2. Okay, so we know the x value. And to find the y value, simply substitute this x value into this equation because it's the equation of this line and we can see that's the point. Okay, so we have the x value. You can take that and substitute it into the equation of the straight line to find out the y value. So that's y is equal to 4 times 2 minus 14. 4 times 2 is 8. 8 minus 14 is negative 6. So y equals negative 6. And so we know the point of intersection. Okay, that point over there is simply just 2 and negative 6, and this is going to help us. Now focusing on this graph, we're going to do a similar thing to what we did to f because this graph also has this line as a tangent at this point. So what this means is that the gradient of g, right, we're saying the gradient of g, we'll find out what that gradient is. The gradient of g at this point, which we now know the x value of, the gradient of that is 4. Okay, so remember that g of x is equal to ax squared plus bx and then minus 18, right? Minus 18. So the derivative of this is going to be 2ax plus b. Okay, there is no x after the b because the x will fall away. And now we know exactly what the gradient is. We know that the gradient at that x value of 2, right? So we'll use this as an opportunity to substitute 2 in. And then g prime of x, that gradient is specifically equal to 4 at that x value of 2. So 2, so those multiply, and that's 4a plus b. We have our first equation. Okay, so we will use this equation and let's go ahead and formulate another equation. Okay, so how can we find the second equation that will help us to solve for a and b? It has to be an equation including a and b. So again, we're going to be using this graph of g. What else do we know apart from the gradient at this point x is equal to 2? We also know the full point. We know that this point is 2 and negative 6. So why don't you substitute this as an x and a y value into your graph of g? See, this forms two equations that's going to be used to find 2 points. So g of x, well, we don't have to write it, it's already there. So we're just going to say, substituting negative 6 as the y value. Negative 6 is equal to, and I'm following here, a times 2 all squared plus b times 2 minus 18. And then we'll simplify, it'll be in terms of a and b, but it's fine. Okay, so those multiply and they'll give you 4a. Those multiply and give you 2b. And then we can take the negative 18 over to give us a positive 18 minus 6. Positive 18 minus 6 is 12. So this is what we have. Okay, that's equation 2. Now, you can choose to make one thing the subject. It's also fine. But I'll also show you another way of working through these simultaneous equations because that's really what it is. So what we can just say is take equation 2 minus equation 1. So the left-hand side of equation 2 minus the left of equation 1. So that's going to be 12 minus 4 is equal to, and then again here, that's 4a plus 2b minus these 2. Now, of course, you put that in brackets, but after the brackets, what's going to happen is that minus distributes in and becomes negative 4a minus b. So you see what happens here? You've got a 4a and a 4a that will cancel, and this will solve for b. 12 minus 4 is 8. 8 is equal to 2b minus b is b, and there we go. We found b. The value of b is 8, And we can just take this and simply substitute it into equation 1 to find this. So call this equation 3, and then we'll just put equation 3 into equation 1, and this will help us to find A. So 4 is equal to 4A plus, and the B value is 8. So that is just going to be 4A, and if you take that over, 4 minus 8 is negative 4. Therefore, you can see that A is going to be equal to negative 1. So there we go. Those would be the values of A and B given the information that they gave us. Moving on to the next question. And we're on question 9. Question 9 says, given f of x is equal to, and we have a cubic, okay, but they also factorize it for you, which is nice. I like when they do that. Okay, so we have show that k is equal to 1. Okay, show them k is equal to 1. So it's going to be factorized and look like this. In other words, they are asking you to factorize this, because here are the factors of this cubic function and it includes k. So factorize it and you'll find out exactly what k is. When factorizing cubic polynomials, you take, okay, using the long division method, you take the last number, right, the constant, and you get the factors of that constant. Now, normally you would have to take all those factors of negative 4, like 1 and negative 1, 2 and negative 2, 4 and negative 4. And you literally have to just substitute them until one of them give you a 0. Because if it gives you 0 when you substitute it in here, then it means that that number is a solution. It's one of the solutions to this cubic function, like when it's equal to 0. But now we don't have to do that because they already told us to show that k is equal to 1. So we know that k is equal to 1. So the only factor we're going to try here, or the only number we'll try, is 1. You don't have to start testing out anything else. And you see that when we try at 1, it gives you 0. So it works. Okay, so what I'm going to just do is, I already know, well, I'll show them that I actually did try it. I'll say f of 1 gave me 0. Okay. Okay, so I'm also just going to put the calculation of that. So now that we know that that works out, you can factorize this using long division. I mean, it's only for 2 marks. So this one, I'm not sure if you're really supposed to factorize it. But okay, if we were factorizing just for, a little lesson on factorizing, you draw a backwards L, like an L backwards. We're going to use long division here. So when factorizing this, you're going to put the number that the factor that you substituted in of this negative 4 that gave you 0, which is this 1 here. So we'll put this 1. And then here we're going to list the coefficient of our cubic function. So the coefficient of x cubed is 1. Coefficient of x squared is negative 6. Of x is 9. And the constant is negative 4. Okay, so first we drag down 1. And then 1 times 1 is positive 1. 1 minus 6 is negative 5. Negative 5 times 1 is negative 5. Negative 5, and then this is a positive 9. So we're saying negative 5 plus 9, which is going to be 4. And then 4 times 1 is 4. And 4 minus 4 is 0. When you end up with 0, then you know that this is correct. Okay, so if we factorize f of x is equal to, we already had this as a factor. So if this works out, what this means is, because 1 worked out, it means that x minus 1 is a factor. Okay, because when you find your factors, you're going to put it as x minus 1, and then you have x plus or minus something, right? And when you're solving for x, you will finally say x is equal to 1. That's why when we substituted 1, it gave us 0, because x minus 1 is a factor. So we have one of the factors already. So that is x minus 1. And then the other factor we get from these, okay? So from the coefficients of these. So this is going to be a quadratic polynomial, and these are the coefficients of it. So the a value is 1, meaning you just have x squared. The b value is negative 5, meaning you have minus 5x. And the c value is positive 4. So that's what it looks like. It's in the form of ax squared plus bx plus c. So this is what we have. And we're going to have to factorize that further. Okay, so fully, because they already factorized fully as well. This is x minus 1, and then when you factorize these two, it's just going to be x times x, and then factors of 4 that give you negative 5. So they should both be negative, the two factors that you have. You can try negative 4 and minus 1, because negative 4 minus 1 is negative 5, but negative 4 times minus 1 is positive 4. Therefore, if you factorize, you see that these two are exactly the same. So they can be written like this. They really just multiply. So you have the x minus 4 and x minus 1 squared, just like they have there. So now we can clearly see what k is. K is 1. Okay, so you can say this, and you can also tell them, but this is what you guys told us about f of x. You said f of x was equal to x minus 4 and x minus k all squared. So since we can see that, that therefore concludes that k is equal to 1. Okay, I really think this was unnecessary. I felt like when it was a factor already, that was already proof enough that k was equal to 1. Okay, so that is it. Moving on to the next question. Okay, the next question is calculate the coordinates of the turning point. Okay, we already have the full equation. We don't have to multiply out. It's already here. So let's rewrite that first. And now we can calculate the coordinates of the turning point. So you're going to derive this function. So f prime of x is equal to, remember the idea behind it is, at the turning points, the gradients are equal to 0. So you derive to get the gradient of that function, and then you set that gradient equal to 0. Okay, so let's derive. That's going to be 3x squared, then minus 12x, and then plus 9. And then we set the gradient equal to 0. So 3x squared minus 12x plus 9 is equal to 0. Then we see that we have a common factor of 3 all through, so divide both hand sides by 3. Therefore, we have x squared minus 4x plus 3 equals 0, and then we'll factorize this. So this is going to be x, and we have 3 and 1, and they're both negative because only the middle is negative. Okay, so these are the factors that we have, and these are the solutions for x. X is equal to 3 or x is equal to 1. Now with the way they already wrote this, you can already see that you have a situation where this is that kind of graph that has a turning point that is also an x-intercept. Okay, so that's that x minus 1. This one, the one that is squared, it's always going to be the one that is a turning point and an x-intercept at the same time. Okay, so we have these two as the x values. Okay, and let's go ahead and find the y values because they want the full coordinates. So take these x values and substitute them into f of x. Okay, so yeah, I don't know why I said substitute this one. We don't really need to put this one in. We already know what that point is. It's an x-intercept and a turning point. So we only need the 3. So f of 3 is therefore equal to negative 4. And that is it. So we'll tell them our stationary points are 3 and negative 4 and 1 and 0. Okay, so that's what we have there. Moving on to the next question. Okay, 9.3 says, describe the concavity of f at x is equal to negative 3. Okay, so they want to know whether it is concave up or down at x equals negative 3. So remember with concavity in the parabola, for example, parabolas that look like this are concave up and the ones that look like that are concave down. So with a cubic function, you will notice there's two types of concavity there. What we can just do is find out whether it's concave anywhere without even using the graph. We can just find that point of inflection. The point of inflection is the point where the second derivative of your function is equal to 0. At this point is where the graph changes concavity. So here is how we can do this. So we have the first derivative. So let's derive this again. That's going to be 6x minus 12. So 6x minus 12 is equal to 0 at which point? So that's going to be 6x is equal to positive 12. And if you divide both hand sides by 6, 12 divided by 6 is 2. So it changes concavity here. So rough sketch of this is, you know that this graph is a cubic function that it has an a value that is positive. So it looks like an n, right? That looks like that. If you know that it changes concavity at x equals 2, so it means that it's concave down all through here, then concave up all through here. Where would negative 3 be in reference to this? Would it be on the right or on the left of this? It would be on the left. So negative 3 is maybe somewhere that side. Okay, so that's where you'll have negative 3. Do you see that the graph is concave down on that part? So we can therefore tell them that the graph f will be concave down at x equals negative 3. Okay, so that is the answer there. Moving on to the next question. The next question is to draw the graph of f, label all turning points and intercepts with the axes. Okay, so we already kind of know what this graph looks like. Well, let's go. So you just need an x and a y axis. You do not need to be writing too much points down. It's unnecessary. So you know the shape of the graph. It goes like that, right? So we have a graph that goes like that, but let's just see the places that it passes. So we have the stationary points. We know that one of it is an x-intercept and a stationary point. That's at x equals 1. And then the other one is this. Okay, so these are your two stationary points that we have. 3 and negative 4 and 1 and 0. So 3 and negative 4, 1 and 0 will be here. 3 and negative 4 would be here. So 3 and negative 4, we'll put that down. Then we have, we can just put our x and y axis. Then we are going to have this graph's y-intercept, because you also need to put that down. The y-intercept, if you make everything equal to 0, it's going to be negative 4. So it has a y-intercept at negative 4 over there. So now from this, you can already see what the graph is going to look like. This is a turning point. And then at 3 and negative 4, we have another turning point. And you know that the shape of the graph looks like that. So your graph is going to go up and then hit the turning point, curve, and then hit the other turning point and go up. Okay, so it's easier to actually just draw the graph first and then put down the points. So here we'll have the 1 as the x-intercept. The y-intercept is negative 4. And then a turning point of 3 and negative 4. And then, of course, we also have that other turning point, which we already found. We already know what that is from here, from the factors. You had x minus 4 and, of course, that x minus 1 all squared. So this is going to be x equals to 4. That is the other x-intercept that we have there. So we can just put that down. That is 4. Okay, and that's our graph. Those are all the points that we need. Okay, moving on to the next question. Okay, the next question, 9.5, says, calculate the maximum vertical distance between f and h for where x is greater than 1 but less than 3 if h of x is equal to negative 2 f prime of x. Okay, so maximum vertical distance, that's what we're looking for. Between f and h, between this interval and h of x is equal to this. Okay, so you see what h of x becomes, right? So you have the derivative of f, but then it's multiplied by negative 2. Okay, so let's look at what the derivative of f looks like that. So we can get that. And if you multiply it by negative 2, because that's what they did, they just said minus 2 and then multiplied it. This is what we're going to get. Okay, I'm just going to focus on the important points because I'm not going to sketch this whole thing. So let's look at that. That's going to be negative 6x squared. So first of all, it's not longer concave up, it's now down. And then plus 24x and then minus 18. Okay, this is what h of x now looks like. And we need to find the maximum vertical distance between f and h. Okay, we already have the graph of f. Let's actually just look at it with this. I'm going to get this graph and see what this looks like. Okay, so this is what we have. Now, there's certain things you need to note about this. Because of the transformation that happened here, it was just multiplied by -2. Certain things are going to stay the same with that derivative. Remember that if it was just the derivative of f, right, it would be a concave up parabola. And it's very important to note that the places that it will have important points, right, these x-intercepts would be here, first of all, at 3, because you see the turning point of your cubic function is going to have the same x value as the x-intercept of your parabola, okay, your derivative of f. And it will also pass here because this is another turning point at 1. So it would have looked like this. Okay, I don't know what the y value would have been, the turning point, but this is what it would have looked like. But now we multiplied a -2 to it. So instead of it looking like that, it's going to turn around. Now, all of these other points, like whatever this was, it's going to be multiplied by -2. Okay, so if it was just multiplied by 2, it would just go further down. Okay, so all the y values are just going to be more stretched out. This will make the graph more narrow, really. But it will still pass 1 and that, because those y values won't change since they're already 0. Okay, it's like saying this is 1 and 0. All the y values get multiplied by -2. If you multiply 0 by -2, it's still 0. So that's one important point. Regardless of how it looks, it's going to look like that, right? But it's still going to pass 1 and 3 on the x-axis. Still going to look like that. So that's what h is going to somewhat look like. And they want us to find the maximum vertical distance. So we want to find the distance, and it's between this. So where x is greater than 1 but less than 3. Interesting point. Let's just see what happens here. Do you see that at these points, the graph of h, right, has higher or greater y values than the graph of f? Okay, so you can say h of x minus f of x, since it has higher y value. So we're going to say the h minus the f, okay, to find that vertical distance. And you can see that it's greater than it all through from 1 to 3. It's still greater than it. It still has a greater y value all through. See, that's a greater y value than whatever y value is here. This has a y value of 0. This one has a y value of -4. Okay, so I would just want to think about it like that. Since they didn't really say find the difference between f and h, they just said vertical distance between f and h. So I was just trying to find out the order in which I should say that. So to find that distance, because I can see that h is bigger than f all the way from 1 to 3, I'm going to say h of x minus f of x. And let's go ahead and find this. So this is equal to, and this is h of x, we'll take that, and f of x as well. So minus f of x, and that is the cubic. So we'll also get that. Okay, so this is what we have. And this is just for the distance first. So -6x squared plus 24x minus 18. And then when we multiply in, it's going to be minus x cubed plus 6x squared minus 9x plus 4. Okay, straight away we see these two will cancel. Anything else? Okay, nothing else cancels. So d is equal to, and you're going to have -x cubed, and then 24 minus 9, which is 15. Okay, so positive 15x, and then -18 plus 4, which is -14. Okay, so this is what we have. We have a cubic function and looks like this. So you see that this one, a is less than 0, it's negative. So instead of it looking like this, it's going to look the other way around. It's like a backwards n. So like that. Okay, so you'll see that it will have a minimum here and a maximum here. And let's just keep that in mind. Okay, so now we found the distance. We need to find the maximum distance. That's what they said to find, the maximum distance. So what this really means is when you take the graph of h and you subtract by the graph of f, it gives you a polynomial that looks like this. Now this polynomial happens to be a cubic function, so it can be graphed like this. And we're going to use this cubic function to find the maximum, okay, distance that it's going to have. So in a literal sense, yes, it is actually the distance, the biggest distance between these two graphs. It really is that at the end of the day, but those distances have now been represented as a cubic polynomial, and we're going to use that. So this is like a maximum and minimum problem. To find that maximum, we're trying to find out whether gradient is equal to 0. So you're going to derive this. Might as well call it d of x, but it's fine. D prime is equal to, so negative 3x squared plus 15. And then that's it. Then to find the maximum, you're going to set the derivative equal to 0. Negative 3x squared plus 15. Again, we're just trying to find whether gradient is 0. Okay, so because that's going to be a turning point. And then here we have, well, you can just divide both hand sides by negative 3 to make this simpler first. And now you have x squared minus 5 is equal to 0. And then solve for x. Okay, so not a square number, but you can still solve for x. You can take negative 5 over. So x squared is equal to 5. Then square root both hand sides. So square root. But this is an equation, so you need to consider the positive and negative solution. So this is x is equal to either the negative square root of 5 or x is equal to the positive square root of 5. Now, based on how our graph looks, well, they put a restriction, so it's fine. But you can already see here that we have a negative one and we have a positive one. The one that has a maximum would be positive. So why don't we just, well, we could have also just looked at that. They said x ranges from 1 to positive 3. The negative one won't work. So use the positive one because it's within the interval they asked for. So if you take that and you substitute it into your expression for the distance, that's going to give you your answer. So this is the distance is equal to this, and then we'll just find distance if we substitute that. So negative root 5 cubed plus 15 and then root 5 and then minus 14. And let's go ahead and see what that is. Okay, and the answer here is 8 point and it's going to be 36, rounded off to 2 decimal places. So we can tell them, therefore, the maximum distance is 8.36 units. Okay, and that is it for that question. And that is it for calculus. They actually didn't give more questions. They just question 8 and 9 for calculus, and that was it. Okay, so that is it for calculus for this paper, and I will see you guys in the last section, probability.